Hello, so today we are going to do this problem called valid perfect square from Leetcode may challenge. Given a positive integer, when I write a function that returns true if the number is a perfect square, otherwise it should return false. And we do not want to use any built-in library functions such as square root. Okay, we do not want to use this function, and the function just says true if it's a perfect square and false otherwise. Okay, so what is actually a perfect square? Is it just a square or what is it? Uh, true if okay, so 16 actually it's 4 multiplied by 4. So um maybe yeah, let's use calculator here. 14 is not, so that's why we should return. Okay. Um One thing we can certainly do is just start from 0 to n to the number itself, and maybe the number divided by 2, because here if I do 16 divided by 2, I get 8 to the number divided by 2 and multiply it by itself and see if it's equal to the number, right? Okay, so let's say so for I in the range of number maybe divided by 2, if I multiplied by I is equal to num, then just return true, otherwise return false. I'm not sure if this is enough, but let's try it. I think this could. Okay, and with 14, 9, 8, 3, 1, 0, 12. Okay, so it looks like it's wrong for this number, where it's correct for the other ones. So this is the third one from the last one. So it's wrong for 1, for the value 1 itself. So 1 actually is, but here since we go until divided by 2, we don't get the solution. So one thing we could do is just fix it by doing that. By not dividing, but that would be false still because, yep. So actually, let's do +1 here. That should work. Okay. No, that's not working at all. It doesn't work with 0 because for 0 it should be false. Okay, so if okay, let's try this. Yeah, I don't think it's probably too much to just go through the entire, yeah, definitely time limit exceeded there. It doesn't make sense to go through the entire thing. Add this to the list. Okay, so we definitely get time limit exceeded. Actually thinking about this more, I think binary search would be a good way to solve this. So what we can do is, what we are binary searching for is a number such that mid multiplied by mid would be equal to the number, right? Now, how for binary search we need to find a formula that is false for some data points, and then it becomes true, and once it becomes true, it stays true. So we will be searching for either the last false or the last or the first true value here. And so how can we construct that function? So that function would be f of x. Basically, if you have, so 2 multiplied by 2 is equal to 4, right? So if it's different than 4, no, not really. So basically what we can do is for f of x to be less than or equal to number. What this would mean is that increasing x would give us a bigger number. So this would be false, and then once it becomes, actually it's this. So this would be false, so the number is smaller, and as we increase, it starts becoming true, and once it becomes true, it stays true. And then what we are looking for is the first true value here. So what we will be doing here is doing binary search, starting from maybe 0 to num, and of course here let's just handle 0 and 1. So if num is equal to 0 or it's equal to 1, we can later maybe remove that condition. We want to return. So for 1 it's true, for 0 it's false. Now here we want to do binary search template. So mid would be low plus high minus low divided by 2. And we will say if our f of x, which is mid multiplied by mid, bigger than or equal to num, then this means true, right? So if it's true, maybe you are here, and so we want to move left, right? Or maybe you are at the last one, so we will want to stay at mid but go left. So going left means it's the high value that gets changed to mid. Otherwise we want to move right, and so it's the low value that changes to mid plus 1. And then at the end we can just return, we want to return true or false here. So we want to return if low multiplied by low is equal to num. I think that should be it. Okay, so that gets time limit exceeded. Okay, looks good, looks good. Okay, so this looks good, and it doesn't get time limit exceeded, so let's try. Okay, so that's accepted, yep. So binary search should find this in log of n time, and n here is the number value here. So that's why it's pretty fast here with binary search. Yeah, I think this is good enough for this. So yeah, the right approach is using binary search to find the square root number. Yeah.